into their structure and bonding. So we're going to start with substances that have a metallic structure and bonding. And examples are aluminium, copper, iron. Okay, these substances are metallic bonding, and we're then going to look at substances with ionic structure and bonding. An example is magnesium chloride. And magnesium chloride, I'll just take some out so you can see it, is just a white solid. Potassium chloride as well also has an ionic structure and bonding. And they're not very interesting substances, they're all white solids. Then we are going to move on to looking at substances with a giant covalent structure. Unfortunately, we don't have any diamonds to experiment with, so diamond is an example. And graphite, which is what's found in your pencil, but this is actually an electrode that we're going to use later. So I'm going to call it giant covalent. And then finally, substances with a simple molecular covalent structure, and also not particularly interesting, I've got carbon dioxide gas, oxygen gas, which has got a simple molecular covalent structure, and water. You can see the water on there, H2O. So we're going to test some properties of the substances. So the first one I'm going to do is look at whether something conducts or not when it's solid, or when it's molten, which means in a liquid state, or whether it's in aqueous solution, that means when it's dissolved in water. So the equipment I'm going to use is basically just a little bit of information about what electricity is. Electricity, or an electrical current, is just a flow of charge or a flow of charged particles. Okay, so just some examples of charged particles you may have heard of. We could have ions, or we could have electrons, and electrons, if they're free, are electrons that can flow. Sorry, it's okay.
In the middle of filming?
I am. I'm getting proper. Sorry, do you need to come in here for that? Because I'm like.
It's alright, I wanted the computer, but it's fine.
Because I've. I think what room I was in, I've been interrupted loads of times.
Do you want me to lock that door?
Yeah, if you could.
Shall I? I've got the key.
And I finally got it into my head what I was saying, and then I'm like.
I'm so sorry. I had no idea.
I think everyone needs to. I think we all need to try. I think we want to. Do you know, we need to have a filming day.
And just do completely bizarre.
Yeah.
Do you want me to lock the other door as well?
No, just that one.
That one. Okay.
Right. So I've stopped that one. Oh, I'm filming now. So we're going to test some properties of the substances. So the first one I'm going to do is look at whether something conducts or not when it's solid, or when it's molten, which means in a liquid state, or whether it's in aqueous solution, that means when it's dissolved in water. So the equipment I'm going to use is basically just a little bit of information about what electricity is. Electricity, or an electrical current, is just a flow of charge or a flow of charged particles. Okay, so just some examples of charged particles you may have heard of. We could have ions, or we could have electrons, and electrons, if they're free, are electrons that can flow. Sorry, it's okay.
In the middle of filming?
I am. I'm getting proper. Sorry, do you need to come in here for that? Because I'm like.
It's alright, I wanted the computer, but it's fine.
Because I've. I think what room I was in, I've been interrupted loads of times.
Do you want me to lock that door?
Yeah, if you could.
Shall I? I've got the key.
And I finally got it into my head what I was saying, and then I'm like.
I'm so sorry. I had
think everyone needs to. I think we all need to try. I think we want to. We need to have a filming day.
And just do.
And also, if I bring the bulb into this frame, I can see the bulb lights. Now I know my circuit's working. I'm switching it off. I'm going to see if it first of all conducts when solid. I'm going to use the material in question to complete the circuit, and hopefully we can see the bulb and the ammeter now. I'm going to switch on my circuit really carefully, not to touch any of the metal bits, and I'm just going to use the substance I'm trying to contest to complete the circuit, and I can see that charge can flow through this solid metal, so I'm going to add to my results table that yes, aluminium does conduct when it's solid. I could also use copper as well. Copper has also got a metallic structure and bonding, so if I just touch the copper on either side, the bulb lights. So charge can flow through that when that is solid. Now, to test the ionic substances such as magnesium chloride, which has a compound with a metal and a non-metal in it, I'm just going to insert the 2 graphite electrodes and use those to complete the circuit. And I can see on the ammeter, let's move my hand out of the way, there's touching. The ammeter, there's no current. And now to look at an ionic substance. I've got magnesium chloride, which is a compound of metal and a non-metal. If this contains charged particles that can flow, then it should conduct. So let's test that. And all I'm going to do is I'm going to put the electrodes into the solid and use the solid to complete the circuit. So I'm going to bring the bulb and the ammeter next to one another. The circuit is switched on. I'm going to put the electrodes in to the ionic substance, not touching, and you can see that the bulb isn't lighting, the ammeter is showing no reading, so no current is flowing, so there's no charge that is able to flow. So just to add to my results table, that no ionic substances do not conduct when they are solid. Do giant molecular covalent substances such as diamond conduct when they're solid? So diamond, remember, is one of the allotropes of carbon. This is how the carbon atoms are all joined by many strong covalent bonds. I've already got some properties on there. It does say never conducts electricity. If we did want to test it, another substance that's also got a giant covalent structure is silicon dioxide. So you can think of sand as just little diamonds. Does this conduct or not? Let's use it to see to complete the circuit. Am I getting a reading on my ammeter if I insert the carbon electrodes? No. So that proves that that doesn't conduct when it's solid. So I'm going to put no. And then finally, considering a simple molecular covalent substance, well, actually the air is made of a simple molecular covalent substance. We've got some gases in the air. These are all simple molecules. You can see that the air doesn't conduct. I could similarly test carbon dioxide gas to see whether that conducts. Which may be more interesting though is seeing whether pure water conducts. So I'm going to put the 2 electrodes into the pure water, and I'm going to use the water to complete the circuit. And my hand is in the way, but you can see that the bulb doesn't light and there's no reading on the ammeter. So I can see that the water, technically, I'm not testing whether it conducts when it's solid, but if I did that with ice, then I would get the same result. So I'm just going to add to my results table, no. So looking at conductivity again, but now we're going to see whether the substances conduct when they are in a melted state, or if they conduct when they are dissolved in aqueous solution. That just means dissolved in water. Now, this is tricky because actually I can't melt any of the substances because their melting points are actually too high, but I will prove to you later on that the melting points are high. So I can't actually melt the iron, the aluminium or the copper because the melting points are too high, but you'll have to take my word for it. So metallic substances, if I did melt them, they would conduct when they're melted, and when they dissolve, they'd also conduct. The giant molecular covalent substances, the sand and the diamond, the melting points are too high, but they don't conduct. Okay, and the simple molecular substances, well, actually, even when they're gases or they are liquids, as I've just proved, they don't conduct. However, I am going to show you something interesting. The ionic substances, as I said, when they are in a solid state, let me move the table out of the way. When they are in a solid state, they do not conduct electricity. Okay, so just to prove that once more, solid ionic compound, bulb is not lighting, okay, no current. Turn my circuit off. What I'm going to do is I'm going to make the ionic compound part of an aqueous solution. So how am I going to do that? I'm just going to take the magnesium chloride. I'm just going to put a couple of spatulas full into water. And what actually happens is the ionic lattice actually splits up and the ions become part of the liquid. And when they do, because the ions have become part of the liquid and the ions are charged, I've got charge that can flow. So we should see charge flowing should conduct. And I'm going to put that in, and you can see that the bulb is lit and I've got an ammeter reading of 0.08. So that means that ionic substances actually do conduct. So I'm going to add to my table yes, and this is an interesting property of ionic substances. They don't conduct when they're solid, but they do conduct when they are dissolved and when they are molten as well. Okay, so both molten and dissolved. So you've just seen that. All I need to do is dissolve an ionic substance in water. So that would suggest that seawater does conduct electricity as well. Just to finish, just to prove that that wasn't just a fluke, I'm just going to show you another ionic substance. This substance is potassium chloride. The ions in it are the K+ cations and the Cl- anions. I know it doesn't conduct when it's solid because I've tested it, but I'm going to dissolve this if it's soluble, put it into some water, and hopefully now the ions can flow. So the K+ ions and the Cl- ions are floating around now in that solution. I have my, I'll tilt this back, I've got my ammeter, I've got my power pack, my DC circuit, and just let me remind you of a circuit diagram. If you wanted to describe this experiment in an exam question, you could maybe just draw a circuit diagram. I'd build this circuit with graphite electrodes. But finally, to show you that it works, do I have charge that can flow? Okay, I can see the bulb is lighting and I've got a reading of 0.05 on my ammeter. So ionic substances do conduct when they dissolve. While I've got the same beaker, if I add some sand, sand as we know is insoluble, so I can't really test whether that conducts when dissolved because it doesn't dissolve. Okay, we're going to test the melting points of the 4 types of substances now. A really kind of crude way of testing the melting points is just to heat the substances. So I'm going to start with a metallic substance. I'm going to start with copper. And all I'm going to do, I've got some copper turnings here, okay, and I've just put some copper in a boiling tube And all I'm going to do is, to cause a change of state, I'm just going to apply some thermal energy for about 30 seconds. I'm just going to heat it with the Bunsen burner, and I'll try and bring the camera a little bit closer without burning my phone that I'm using to film it with. So all I'm doing is I'm causing the particles, or the ions, actually the positive ions in the metal, to vibrate more quickly. And if the forces of attraction between the ions is weak, then we would expect probably this Bunsen burner is about 350 degrees, I would estimate. And I've been heating it, and you can see that it's got really, really hot, but it's not melted. So I'm just going to conclude that metallic substances have got a high melting point. Now I'm going to do the same for an ionic substance. I'm going to test the melting points of the substances. A really simple experiment. I'm just going to heat them with a Bunsen burner. I'm going to start off with a metallic substance. I've got some copper, and I'm just going to put some copper in a boiling tube, and I'm going to heat the copper in a Bunsen burner flame for about 15 seconds. Okay. And a simple way of testing whether the melting point is low or high is just transferring some thermal energy and seeing if we can overcome the forces of attraction between the particles, and heating this for a while. The camera's getting a little bit hot, so I'm going to bring the camera away. And you can see that actually if I heat this, it doesn't melt. So I'm going to conclude that our metallic substances have high melting points. Okay, another clue is that they are solid at room temperature. So if something's solid at room temperature, we can conclude its melting point must be quite high. Now for an ionic substance, so back to the safety flame for a second. The ionic substance I'm going to show you is, bring it into the frame, it's that white crystals of magnesium chloride with Mg2 plus ions and Cl minus ions. Just get a good secure grip, turn it onto a hot flame, open the air hole so I've got complete combustion. And what I'm trying to do when I'm melting something, I'm trying to provide enough energy to overcome the forces of attraction. In this case, the particles are ions, and it's not melted. So I'm going to conclude that the forces of attraction between the ions must be really, really strong. Moving on to a giant covalent substance. Okay, back to my safety flame again. The giant covalent substance I've got is silicon dioxide, which is similar to diamond, okay? And I've got my safety flame on. Remember, you can see safety flame, yellow flame means I'm getting incomplete combustion. And I want a hotter flame, complete combustion now. I've opened the air hole, and I'm just getting carbon dioxide and water in the flame, but let's not focus on the flame. Let's focus on, am I overcoming the forces of attraction? Are the forces of attraction weak? Well, I can see that actually not melted at all. Okay, so that sand actually has got a very high melting point. So does diamond. And finally, we want to see, do our simple molecular covalent substances have high or low melting and boiling points? Now, we know that carbon dioxide is I'm going to turn the Bunsen off so it doesn't distract. So we can see the carbon